Hi guys. Today we're just going to continue, or I'm going to continue finishing my Python script to process the ribo files using the ribo.py interface, and throughout that time I'm going to be using this repository as a reference to see, okay, like what are the arguments that I need to prepare, and then what are the specific functions that I need to call to get the data that, or retrieve the data that I really do need for the bigger pipeline. But yeah, not much talking once again, or at least from the start, and then I will get to it. Okay, while it's waiting, I want to kind of summarize my plan for today. It's not too much, it's not a lot at all, but in the last stream, I know I talked about using ribo.py to get the occupancy counts, but the other part that I didn't talk about that I want to touch up on right now is how I'm going to get the sequences. So if I look at my code for the embedding generation, okay, cool. So I'm in a login node. Okay. It's taking a while. Cool. Okay. All right. So if I go into this code right here, okay. Okay. So Orthrus, since we've successfully set up the environment, let me talk about one of the dependencies that I actually do utilize. I definitely have talked about it in previous streams, but I'll talk about it again. And so one of those things is genomic. And if I search it up here, so the documentation by the authors, right, they describe it as a library for easy and access to genomic resources, such as sequence, data tracks, and annotations. And so the sequence part of this is actually what I wanted to talk about today, and how I'm actually getting the sequence. I'm not going to go into a compute node right now because I don't want to waste compute credits just for a demo. But what I do want to talk about is like how I actually retrieve the transcripts. So right now I'm working all the tests that I used for embedding generations. It was all conducted on a sample sequence that I actually don't get from my lab, and so this sequence itself is just purely from the the genome kit library. And so it's this important line right here where I have from genome kit, and then part of genome kit includes genome and interval. So let me actually look at the here, let me just do this. Okay, cool. And so here I'm importing genome. Hold on. Okay, so here, right, I'm importing the genome class, and let me see if and this. So these two Python files, right? So what does that mean, right? Well, what am I working with? A genome, right? So that's what I'm trying to analyze. And so within that genome, there's a specific interval because it has sequences, right? And so I'm just importing interval so I can get a specific sequence, subsequence of the entire genome. And so this is what this code does here. So I set a genome object, right? And so the reference is gencode v29. This I'm gonna have to change because I talked to my advisor and he doesn't know for sure. So I'm gonna have to confirm that myself today using ribo. But for every transcript, there's a reference that it follows. And the reference versions don't matter too much. I think the most, I think the version that I could use and up to date is v40. But when I was training XNAS, I think it's been forever, but I believe the version of GenCode that I was working with the band files was v48. But unfortunately, I think it was like in the second stream, but I tried when I was looking into this genome kit library, the documentation said it doesn't support anything above 40, and so that's unfortunate. But when I talked about that problem with my advisor, he said that it didn't matter too much, because for the most part, the versions at that level are largely the same. And then this interval is, well, I think it's self-explanatory. So within that sequence, so from nucleotide, whatever this number is, to nucleotide this number, I'm just collecting that entire sequence. And then that's what I'm printing out right there. And once again, I can't show you guys because I'm not on the compute node right now, but I don't erase credits just yet. Anyways, so that's that. So that's genome kit. So let me go back to my whiteboard. That was a very dumbed down explanation of everything so far, but main point and why I'm talking about all this is just drawing a visual for this pipeline. So two things, right? ribo, and then genome kit. Let me genome kit. So these are the two things that are going to be used in this pipeline, or as far as my knowledge goes, right? Genome kit, like how I just explained, is going to be used to yield sequence data, right? So when we talk about Orthrus, and we talk about producing embeddings for each nucleotide, Orthrus takes in a transcript sequence of arbitrary length. And then ribo yields the reference names and ribo counts / coverage data. And that coverage data is what I talked about in the last stream with this stuff right here, but it's whatever. And so these two things, so if I have an Orthrus model, 6-track So this sequence will be fed into Orthris. Orthris yields per nucleotide embeddings. Or that's how I configured it to be. Right? And then I have my, for now, I'm just gonna call it an MLP, but ideally it's going, there's other layers that I need to add in. Like, I know for a fact I need convolutions. I can even add transformer layers, follow strategies used by the team that developed translatomere, but that's for another stream, most likely. But I'm just gonna call it a predictive model, right? Because that's the goal. So okay, predictive model. And so right now it's just a simple linear model, 512 to 2 times n, or we'll call it a, where a is the number of cell lines I have. Yeah. And then the other part is a loss function. So we'll call it loss function. Right? And that loss function will compute the loss. And I don't remember which stream, but in a previous stream, there's just 2 major factors that contribute to that total loss in our problem, which is the total ribosome count and the positional difference, right? So how accurately distributed are those counts across the entire transcript sequence? And then we'll have our training loop, where, let's see, how could I draw this? We'll call it training loop. So training loop, and then I intend to use PyTorch Lightning to make that. So that loss will be fed, and then we use that loss to update the parameters, right? And then, so this will be our tensor. So output tensor total loss and our gradient, right? And then that will be used to update our parameters. So in so yeah, that's the goal. Yeah. Okay. So this looks about right. Obviously maybe I'm missing a few things that are very crucial, but for the most part, these are the major components. And I have some of these things done, right? So Orthrus, Orthrus is good. The loss function is good. The predictive model, I have it configured so that it gives me a good output. And it also gives positive outputs. Oh yeah, I'm missing a connection. So, the okay, I drew this wrong. So this is actually where the output tensor will be. And yeah, because the outputs will be used to compute the loss. Oh yeah, other thing. I also need, well no, the ribo counts will be the y true, right? So y true will come from ribo pi, y predicted will come from my predictive model, and then that loss function will be used to calculate total loss or display it at the very least, and then what's really important is the gradient or the gradients, and then the training loop will be used to update the parameters, make new predictions, blah blah blah, and then until training ends, then we calculate PCC. Yeah, the other thing is I need to add Pearson correlation coefficient stuff to my stuff. Spearman's also a thing too. A lot of experiments use it, but at least from what my advisor told me, we're mainly concerned with the PCC. And so, yeah, this is a good plan. Okay, cool. Well, I should probably go into a compute node right now. But, so in this embedding, this is what I wanted to show. And we know that we successfully have a multinomial loss imported. Okay. Cool. Yeah, so let's see, what do I want to do? All right. Let's change stuff, yeah. This shouldn't work because my arguments aren't good. Okay. Okay. Let me think. Okay. So, Mangles. Plan to So the first step, create data directory and symlink. Link just one ribo file for now. And 2 would be to use RiboPy to retrieve proper data or important data from the test ribo file. Then see if I can print it. So I just have to see if I can print it. Then the next would be print it. Prepare arguments to retrieve coverage data. Set y true to cover from true to okay. Okay. Where's that? Okay, nice, found it. Yeah, it's this. Okay. So PWD. Okay. So I need a symlink that, and then we're going to try. Let's try heck 293.ribo. Actually, no, let's just do 8278 right there. Right? Would that work? What? To directory. Or maybe I didn't specify, right? Yeah. Okay, that works. Nice. I have it. And then, yeah, so 82780.ribo. Okay, so this is a ribo file. Nice. So I did that. That's successful, right? Okay, cool. So now I have a data directory in my repository that will potentially contain all the ribo files from lab. Okay, so now that I have a ribo file, then let's just say, okay, what were the goals? Vim goals.text. Actually, wait, no. Let me do that here. So, nice. Okay. Done. So, done. Right? Okay. Alright, now reply. Okay. Let me put up the directory. Hold on. Okay. Cool. Okay, cool. Here it is. So what am I importing right now? Find coverage. Yeah. Okay. Need to prepare proper arguments for calling find coverage. Okay. Let me just copy this in. So that's that. Here's a reference name. Okay. So maybe I don't need coverage. Okay. Wow, I lied. Hold on. Let me. Okay. New plan. This is huge. Right? DD. Nice. And then. Shit. Okay. Okay. What is it called? Ribo.py. So it's ribo.py slash ribo.py.api. Okay, nice. Ribo.py is ribo contains the necessary functions I need to retrieve important features. Current test ribo file from ribo file. Alright, nice. So I guess if someone was like to reproduce this, then the first step before doing any, like assuming that I have a file or a script that works, they would need to prepare the data. So I can like have, when I publish the repo, okay. Okay. Then maybe someone would need to create a data file. And then I would need them to insert. They would just insert their ribo files in it. But the instructions will work assuming that they make it. Okay, that's fine. So what can I have? Experiments, I don't need. Reference name, 100%. So let me list. Okay. List of important. Okay, so what could I use? What do I need, right? List of important functions provided, like that I would use provided by ribo.py. So there's reference name. Oh hold on. Right? 1, 2, 3. Okay, cool. So there's reference name. That would be important, because then I would need that to set the specific reference when working with Genome Kit. So that's important. And then I would also need, okay, I also think the advisor said it's like human apparatus v2, but that probably follows a gen code version that I could use. So that's fine. Okay. ribo.py version, I don't need that. Format version, maybe, but I don't think so. Minimum length, maybe. Maximum length, maybe. Metagene radius, I don't know. Returns to the left start. No, maybe. Oh, maybe. Transcript names, yes, 100%. transcript lengths 100% in dictionary form. Maybe, because I guess the index could be used. Okay, so maybe I can include a list, because what does transcript names return? Well, what is self.transcript names? Get reference names, and then what does get reference names do? Does it return a list? I think it returns a list, right? So if it returns a list, I can iterate through that. So maybe I might not need the indices. Okay. Where am I? Okay. Maybe. Offsets. Print info I could use. Useful. Not necessary, but useful. Metagene? No, I don't need it. I mean, if I look at my notes, right? Do I need it? No, I don't. Region counts, maybe, but I don't need it. Length dist. The number of reads for each length for a given, no. Plot, I mean, I could. Plot, I don't need it. Has RNA-seq? I could. But I'm working with a transcriptome right now, so I don't even need that. Get it? Has metadata? That should be true. Has coverage? Okay. Has coverage? Okay, so this is important. So this is how I can get my coverage, right? Okay. So has coverage. Not necessary, but useful. And then get coverage. Yes, this is useful. And then get transcript coverage. What does this do? What's the difference? Returns coverage. Okay, no, this is exactly what I need. This is the coverage at nucleotide resolution. Okay, so this is golden. This is golden. Okay. This is exactly what I need. So I don't need to... What are the arguments for this? Self. Okay, no, that's not it. So I need the experiment. There's a lower and upper inch. An alias. Is it a Python thing? I don't know, actually. Okay, no, I don't need that. Okay. So I know that my directory for a test ribo file is this. So what's the first thing that I can do? Okay. Okay. Let me just print that out. Ribo file, that's too long, right? I hope this works. Is Python actually taken dots like that? I don't know. Okay. How do I... Okay, so I need a ribo object, right? What is that? What does that look like? How do I initialize this one? So, okay. I have a ribo file. File mode? If it's not there, then I raise... What's the file mode? Is it R plus or R? What does that mean? Okay. Oh, okay, so each ribo object already has the transcript names because it automatically calls that, right? Okay, so what if I just call okay, test ribo, or just I'll call it ribo. And then so now because I have, oh wait, I need to import it, right? So I don't need find coverage. I can't use find coverage. I shouldn't, so I should actually delete these. And then here, so from RiboPy, I just need to, hold on. Actually, I'm just gonna delete this entire line. So from RiboPy, import the ribo class, right? Okay, and so now that I have access to that, so now I'm gonna construct a new ribo object, and then it takes in, so it takes in a file. It takes in a file. So I need to provide the path, right? And so ribo path. So I can just do that. Does that work? I know. Okay, so I have print info, so I can do that. So let me try that. Assuming this works, let me print. Oh wait, no. Print info should print it out for me. So I just do ribo dot print info. How about that? And then I can just write that. Hold on, let me put up the other terminal for you. Okay, so this is my compute node. Did I save it? Let me save it again. Okay. Python version. Oh, oops. This is in scripts, right? Because this is my own prepare. Okay. Prepare ribo has no object. Okay. What's going on here? Ribo path. Ribo. Unable to synchronously open file. Does that work? Nice. Okay. It works. So I have access to nice. Okay. And this is the name. Nice. It has no RNA-seq coverage. Okay, wait, this is great. Okay. This is nice. Okay. I'm gonna get water, but alright, this is exciting. I can't believe this is actually working. Alright. I'll be back, guys. Okay. So So I know for a fact this works. This is nice. Let me think. So this was created Okay. So this was created June 18th? Nice. And then the reference is Apris v1. So maybe... Okay. So can I do print... What the... Okay, but hold on. What is that? Alright. Let's see. I know there's has coverage, so let me print that. So ribo dot has coverage. If it's false, then that's gonna be bad, because now I don't know what to do. Okay, I need an experiment, right? That's it. So it's only that. Okay. $26 and $29. Okay. So would that mean my lower range and upper range is 26, 29 respectively? Okay. So is my experiment... So what if I do... Okay. Hopefully this... So let me test this out first. So I need one has coverage, takes in an experiment. Okay. Right, because each experiment... So ribo dot experiments, and it's a list, so I could do... So is it true? What? It should return a... What? Am I not? Oh, I'm dumb. Hold on. Okay. I didn't even call it. Ribo dot has coverage. Ribo dot experiments 0. True. Okay, so it has a coverage. Nice. And there's only one experiment listed for this specific Ribo file. And so now that I know it has a coverage, let me print the coverage. So print okay, ribo dot get coverage I don't like that formatting. Okay. What does get coverage taken? So it's experiment. So let me and then it takes in okay, and then it needs to lower. So 2629. Okay. Oh wait, I need to call it, right? Because there's right. Actually no, I don't need it. And now it's printing the coverage. Nice. So it's all zeros here. Are there non-zero values? Nice, nice. Okay, so yeah, so in this so in some sequences we can see that some of the values are non-zero. And so that's exactly what we need. Oh wait, hold on. I can't even show you guys can't see it, can you? Here, no, this is okay. Here's what I'm looking at right now. So right now I have the proper arguments to so we know I can verify. So for each Ribo file I can verify if it has a coverage. And then if it does, I can actually get that coverage. And so this is what the coverage looks like when I print it out, right? So it's all this. And then in some of the sequences, right, we can see that the ribosome counts, they're non-zeros, right? And some of the values are zeros. So this looks really, really good. And this is very neat. Okay. So yeah, that settles one thing. And so now the next step is I need to make a tensor out of this. Right? But first I need to work on the script. How is this gonna work? So I need to symlink how is this gonna work? Okay. That looks right. Also, I might take a break to watch the World Cup because this game is low-key insane. But not right now. Shout out Belgium. Holy comeback. Hold on. But not right now. If it gets the penalties, though, then yeah. I'll take a break. Okay. Hmm. Okay. feel stuck right now. Okay. So I should do this. Okay. I think I take a break. Good thing I took a break. I just need to reset my head, but I kind of have a better idea. Um. Oh. Also, yeah, my fault. I should have been. I was taking a deep dive into the repository. Hold on. Let me just. There we go. Yeah, so I was taking a good look at or taking a really really good look at the functions that I would need to use, and but more specifically what they do return. Um. So from my understanding, let me see if I can. Okay. So what is the main thing that at the end of the day, the goal is to prepare labels for the pipeline, the model pipeline. If I can go to Miro. Okay, cool. Let's see. So let me just hold on. Okay. So for each ribo file, right? So assuming I have a data directory prepared such that, okay, so let's say right now in my repository I have a directory that contains one ribo file. Each of those files are symlinks to the actual directory where the data exists on my machine. Now, for other researchers trying to reproduce this, they would have their own ribo files and they would have to go through the process of making their own ribo files. I am not going to be providing documentation for that because I don't have to do that. But it is what it is. But anyways, assuming they have access to the ribo files, you need a data directory that provides this. And then so it's like, I'll have something like a2780.ribo. Another one is another good one. Why is my pen not working? Okay. Also, I will hold on. What is the World Cup looking like right now? Okay. And if it goes to pens, then I'm leaving. I'm dipping in 3 minutes. So 5:37. 5:37. I'm dipping and taking a break. Anyways. So that's one example. Another common one is HEC293T. .ribo, right? And so this is assuming I have this, right? Right. Then for each ribo, so this is like really terrible code, but for ribo file, so I'll do something like for ribo file in data, right? Right. So as I iterate, I need to keep track of the amount of cell lines. So that's easy. If there's a way, I can probably search it up. I just need a way to count the number of links or files I have in my data directory. That's the number of cell lines. And for my specific case, I have two predictions. So 2 times 24, 48. Because I know I have 24 cell lines. So 48's predictions, and then my shape is n by 48. Okay. So, I guess then for each ribo file, I'll set, so ribo, right, will be set to a ribo object, right? So now we have a ribo object. And then now we can call different functions in that. But for each ribo, there's an experiment. And so I choose an experiment, but I think my lab, they only did one. And so there's really just one experiment for me, for every single ribo file I have. So I'll do an experiment. Will be set to ribo dot experiments, and then since it's a list, zero-based indexing, I just take the first experiment there. Okay, and then now that I have that, I can get the coverage. So I'll set a coverage is set to so get coverage, it takes in what code did I write for that? It's, so it takes an experiment, min, max, length, and then false for the alias argument. Okay, now that I have the coverage, so each ribo object has multiple transcripts with each of those, so because it's a dictionary. And so each transcript has its length and it also has its reference. But I'm not sure if each transcript has the same length. Okay, shoot. I do have to go though. It's at penalties, right? Or is there extra time? Okay, hold on. I will be back. But World Cup break. World Cup. Okay. I need to watch this. But I will be back.
Can we get it at 8 p.m.?
I need to do it now.
Okay.
What are you doing?
I'm just like recording some stuff.
What?
I'm like recording some stuff.
Recording for?
What do you think? What is the only thing that I do nowadays?
Because it's gonna be too late. It's 8 o'clock. The Costco will close. It's so.
I don't know. What do I do? Okay. Works. All right. Okay. so need mini batches, right? So, oh, hold on. I would need like so now I have, assuming I have a data set, then call it up then. I need to make a collate function, right? Cause I need to make my custom. I need to make it custom. So
Hi, welcome to this video about PyTorch,
Okay.
data loader, and the collate function. I think this each item consists of a variable x, which is a sequence, and a target variable y, which is a binary variable. So it turns out this is not quite the shape that we need the data to be in order to stick it.
yeah, okay.
It into the network. To do that, we need to pack the data into batches. So that's when the data loader comes in. The data loader, in this case coming from PyTorch, is basically a device that knows how to consume this dataset and put items into these batches. We're disabling the shuffling here just for debugging purposes. So what you basically want to do is, say during training or evaluation, is go over the batches of your data loader and do stuff with them. For example, computing predictions, losses, etc. So let's see what happens if we try to go over this data loader. We find that we get an error, and this error is coming from the default collate function, and the message says that the elements of the list should be of equal size. So the problem is basically coming because we're trying to pass these two elements, and the sequences, in this case this one and this one, have different lengths. So the default collate function that is being used from the data loader in the data loader is not able to deal with that. So that is the fundamental problem that we are dealing with here. So here's one potential solution to this problem. We could refactor our dataset to have a parameter called max length. And what we will be basically doing is whenever we're delivering an item, we pad the original sequence X, in this case with zeros, to match this maximum length in case that the sequence is shorter than it has to be. So let's take a look at that dataset. We're going to print the items. And as we see, that seems to work. All of them have length 10. We can go ahead and try to pass that through our data loader as before. And as we see, that seems to work. It's not complaining. Let's take a look at one batch. That works fine. But now, pay attention to the following. Let's say we take this first batch of 2 elements. In this case, we're padding both to length 10, but we actually only needed 3, because this is 3 and this is 2. I mean, the length of them are 3.
So I need a pad. Okay.
And the same goes, for example, if our batch happens to be this one. We will be basically kind of wasting all these positions here. And that can be sometimes wasteful because it could be that whenever we are passing that to our net, network that we're carrying out computations that we don't quite need, or that could limit our batch size, for example, that we're using. And we might want to take advantage of all our computation capacity and, for example, be able to adapt this length according to what is actually strictly needed. So that is exactly what we're going to do next. So let's take now a look at another solution, which will hopefully also help us to grasp how powerful it is to understand the inner workings of the data loader and the collate function. We have here the original toy dataset that we created before, and let's just print it out to see how it looks like. Each item has a sequence of different lengths that we need to batch together. So if you try to pass that to our data loader, we're going to get our familiar error. So let's try to fix that. So what we're going to do is to add here an argument, to pass an argument here, which is a function that we're going to call dynamic length collate for the reasons we explained a few moments ago. So let's try to implement that. So this function is going to take a batch, as we said before. The first thing we need to do is to figure out which is the maximum length, right, of the sequence that we have in our items. So we have to look at all the items and figure out which is the sequence length. So once we have that, we can actually create our padded X batch, so to speaking. And So to do that, we just go through the items. And what we are going to do is first of all figure out which is the padded length that we need for this specific batch. And that will be basically the difference between the maximum sequence length
the current length.
the
Yeah.
sequence length of the
So the max length is
X at
okay.
hand, right? So the next thing we have to do is to kind of pad it. We're also going to pad now with zeros. And so we're going to add to our original item, to our original sequence in the item, we're going to add the padding part, right? So basically that is all we need for each item. So we're going to append that to our list. And we could return the batch X, that will be the padded X's. For the case of the Y's, it's a bit easier because we just have integers like here and here. So we're just going to collect them. And that is going to be basically our collate function. So let me just put this in a dictionary for the sake of clarity. And that's how we are going to put together our batches. So now we pass that function to our data loader, and let's see what happens. So we put it there, and it seems to work. As we see, each batch has sequences that have different lengths. So each batch, for example, this one has 2 elements, and the first one has been padded with 1, 0 to match the sequence length 3. But in the second example here, we have the first element of the batch to have 5 elements, so that's okay. So that's maximum length for this case. And the second element had originally only 3 elements, so we pad that twice. And same applies for the other example. So that's basically how we can add this very simple logic here to our data loader and tell exactly how we want to put together the items of our dataset. So as I said before, what we actually want to do is then go over the batches of our data loader and do stuff with it. For example, generate predictions from a network. So let's just look at a toy example of how that would look like. So we have here a simple model, which is an LSTM. So we're going to feed a sequence into this model. And we're going to go through the batches and generate predictions for them. So in order for this to work, since we're working with PyTorch here, we need to change the type of these outputs here. So we need to turn them into tensors. So we're going to do that very quickly. And basically that will be it. So with that in place, our data loader, as we see, is going to return tensors now, which have the proper shape. That we're going to bring into the proper shape here. And as we see, that seems to work. So we could look at the predictions of our network in this case, and we see that's working. So to sum up, we learned what the collate function is in the PyTorch data loader, and we also looked at a concrete example on how to put together batches that may come with different, in this case, sequence length, and do that in a way that is efficient in the sense that we adapt dynamically to each batch, and with that bring our data loader to work, and we were able to generate predictions from this little network. So I hope you learned something. Let me know if there are any comments or thoughts on it, and see you next time.
Okay, yeah. This should be fine. And then now if I look at the logic, so what did I want? Okay. Well, there's a few things that I am missing here, but for the most part, this should give me a good idea. Okay. Hold on. Let me turn on my lights. And I also need to get more water. I'll be back. Oops. That looks good. So, okay, so when I create the data set, providing a directory, right? Because it requires the RabbitPi to read it, to create a new Rabbo object. You need path to it, and I have that. Your min and max read length, your IDs. Okay. Let me save that. Okay. For the length, I'm just going to return the number of cell lines, right? And so it's the number... She notes that I need to return that. And then the ribosome profile and count. What is going on with me? Okay. Right? Because. Yeah. Okay. Okay, so now when we actually make the data loader, so we have a dataset class specifically tailored to accommodate for the cell lines, right? Which is in ls data directory. Okay. And so now we need to make it. And so we can say like our data set is equal to, what's it called? Multi-cell, okay. So it's called that. Ribo data set. And then it also takes in the read length max. And then the last thing is our batch size, right? Because no, it's no, we also need it in a K if we want to normalize our values as well. And that's important too. So then it also takes in normalize. Oh yeah, well, I need to implement that, right? And so normalize per track is equal to it's a boolean, so that's default will be false. And so now, oh, I spelled that wrong, right? Okay, and so then we just send in that boolean. So that's the last. That should be the last argument when we create our data set, right? So when we initialize it, yeah. So the transcript ID is so, but that's just optional. Okay. Yeah.
It's already 2 o'clock. Are you done?
Huh?
Are you done?
Yeah, I can help you.
Okay, so I already filled up your car full tank.
Yeah.
I bought salt,
Yeah, so just fill it up.
put it there.
Yeah.
You have to help me.
Yeah, I know, I said I will.
Buddy, you should have come.
We'll be back. I will be back. I have to take care of some stuff.
You're stuck there. There. Here. You need to look for
Okay, I'm back. I just had to help my dad fill up some stuff with because we have like a water filter, and so I had to dump a lot of salt in that filter, but it worked out. We're good now, so continue where I left off. So yeah, I made my data set. All right. And so if I have my data set now, let's see. Then I need my set of data loader. And my batch size is that. Shuffle is equal to shuffle. Then sampler. I don't need it. I don't need that. And then my let's see. I will need to set my collate fn function. I need to set that equal to my multi cell collate. Did I spell that right? I think I did. Okay. And so now we have a data loader. That's so cool. Okay. Well, I need to test it. I'm probably going to run into a bunch of errors. I really hope I don't. But for the most part, this code makes sense. At least to me it does. Hopefully my computer agrees, but I don't know. Yeah, so we have our own custom dataset class, and then because we're working with input sequences or transcripts of varying length, with the help of some YouTube and just like some decent reference, we wrote our own collate class. Not class, our own custom function for that. And this does solve the goal with, let me see if I can put it up. Actually, no, I'm too lazy. But this does solve one of my original goals that my advisor said to do, which is like padding those sequences with zeros. And so I think this automatically does that for me. And so that's pretty neat. I do have to set a custom or a standard length for my pipeline. But ideally, we'd want to feed in the entire sequence or entire transcript. So I don't know what length that would be, but if it can be in the 6-figure digits, then 6-digit numbers, then we're good. That's very, very good. But let me finish this. I need a main function, right? Test it. Okay. And so, let's see, what else do I need? Yeah, that's it. And then I just return it, right? Because then I have my own custom data loader now. So, yeah, and then I just return dataset, data loader. Nice. Alright. Okay, cool. So, we have all of this. I think I've defined everything I want or need. Yeah, and for the most part, I think this works. Okay. This looks good. This looks promising. Let me see if this compiles. Let me fix some errors, but if hello world prints, then I should be good. Okay, let me put up my other terminals on stream. Oh, okay. Okay. Yeah, so I lost connection to my machines. Let me put it up first. Okay, cool. Let me SSH really quick. Hopefully this works. Oh wait, let me. No, I don't want to do that too fast. Let me just. Oh my god. Okay, let me start. Okay. So annoying. Nice. Okay. Nice. All right. Next machine. Okay. What the fuck was I gonna show you guys? Wow, I lost my train of thought. But wow, yeah. See, give me a bit. I don't know. I was gonna do something. I literally talked about it. Oh yeah, I was just gonna check if it works. Okay. Let me just. Okay. I remember now. This is like work in progress. Hold on. Almost done though. Let me save that. Okay. Let's see. Okay. I need a compute node, right? Yeah. Hopefully this doesn't take too long. But what can you do? Nice. Alright. So I have instant access to it. That's good. Okay. Speech. What was it? Prepare? Yeah, so if this prints hello world, then there's no syntax errors, and that makes me happy, right? Okay. 76. Coverage. Oh yeah, I'm missing. Get coverage. Yeah, I just have double parentheses here. That's fine. Yeah, that should work. Let me save this and then try again. 85. Okay. Loaded block cell lines. Oh, I didn't even. Huh. That's fine. That's funny. Okay. I have to actually put in the variable. I didn't even put that in, did I? Yeah. Save. 143. Non-default argument follows default argument. Okay. Where is that? So. Oh yeah, I didn't even. Can I just set it to the default values that I initially had? I don't know. I'm not sure exactly why that's not working. Okay. This looks like it's fine. Alright, and that's gonna print hello world, right? Nice. Okay. So no syntax errors here. Now, let me test the logic. But hopefully this works. I probably should have checked for some errors, but actually no. It's fine. But however, I might have to do it because this is all under the assumption that the data that other people have for their ribo files is clean. And so that kind of sucks for the general audience, right? Let me get water. I'll be back. But I'm glad. I'm gonna test when I come back. Okay. Back. Alright, so let me print. So let me just test it though. What's the first thing we want to test? So I know we don't have syntax errors. I think. So let's say, let me insert some stuff. Okay. This is kind of dumb, but alright. Logic tests. Sure. Sure. Dataset preparation code works. Alright. So I can probably start by defining a data set, right? And I need to feed the data directory, which is just one back, and then we go from one back from scripts, and then we go to data, right? Okay. No. I'll just set, so data set and data loader, because that's what we return. Let me spell that correctly. And we'll call our make multi-cell ribo data loader function. So it takes in what? Two things. What's the shortcut? Hold on. Vim shortcut to go to the most right of the line. I hate doing that. Okay, so I press 0. So I press 0 to go to the left. So let's say I'm in the middle of this, right? So if I'm not in insert mode, I press 0 to go to the left, and then what? Oh, I see. Wait. Is that right? Hold on. Oh, okay. So 0 and then $sign. 0 $sign. 0 $sign. If I want to go to the top, go here. $sign to go to the right, 0 to go to the left. I kind of hate how that's configured, but I guess it is what it is. G, capital G, right? Because that's, yeah. And 0 $sign, but because there's only one type of character, so I can do like, if I insert, and I go, blah, blah, blah. Okay. So, $sign, no, 0 to go to the left, right? Yes. And $sign to go to the right. Cool. And then, like, I know how to delete that. That's cool. Let me just, okay. Nice. So, I don't need this anymore. Yep. Okay. How was it again? $sign. In escape mode. Nice. And then insert mode. Okay, cool. So things. Okay. So my ribo directory. I set it equal to. Well, I don't have to specify one back because I remember, because that was an error when I started writing the script. I can just straight up write data, right? Because yeah, I don't think I need to specify that. That was my mistake. And then my batch size, the default is 2. I will make it 2. And then read length min is equal to 26. Read length max. I'm hard coding it right now, but I'll need to change that later. But I don't care. I'm just testing. And then we'll just set it to normalize per track. I spelled that wrong. Normalize per track equals false. No, capital. Cool. Okay. Now what? And so my current batch of the data set is equal to, and then I can just do this nice little shortcut. I remember data loader. No, my data loader, not capital D. Right, so my custom data loader, I can just iterate through that. And then what do I want? So for each batch, right? So print, and then my cell lines. Boom. It's, what does my data set have? It's cell lines, yeah. Okay. Print data set dot cell lines. Nice. And then let's see. Print new line. Print transcript IDs, right? Print okay. Nice, have a good song playing. Okay. Print I need to look up. So the goal of this was to get y true, and so I'll just have to shape of y true. Post pipeline. Post pipeline. Print. And that batch is true. Dot shape. 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 Mask. Does that look right? Yeah. Let me test that out. Save. Oh. Ah. Okay, hold on. Cool. Save. Bool object is not iterable. What is going on here? Okay. So. Okay. What's going on here? So that. So it's my transcript IDs, right? Wait, I can't do that, can I? It's not gonna work right now. Oh, I see what's going on. My normalized protract. Okay. Okay. That makes sense. Okay. Because I didn't pass in transcript IDs, so of course. Okay. So. Yeah. 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 Okay, hopefully that works. And so, none type. Oh, because I'm not checking if my... I need to check if it's none. Okay. So where could I fix that? Okay, that's not hard. Where's my transcript IDs? Self.transcript IDs. Okay, here we go. Cool. And so... Oh, I'm not in this terminal. Okay. Cool. So I just need to check is equals that. And so I need to check. So if self.transcript IDs, so if self.transcript IDs is equal to none, or actually, hold on. I have to check if transcript IDs is none, right? IDs is none. Then let's see, what can I do? Do this. Then we can set IDs is equal to sorted of all the common IDs. Let's try that. Cell lines is not defined. Do I mean cell line? Where is that? It's the length of the cell lines, right? Cell length of what's it called? Of our dataset objects, cell lines, because it's a list, and we want to take the length of that. Does that work? Has no transcript IDs. No. Where is that? Yeah, I mean transcript IDs. Transcript IDs. Nice. Okay. Cool, 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 cool. We have something working. Oh, shit. I know what happened. Nice. Okay, wait, I think this is working. This is looking good. Okay. Nice. Okay. Let me think. So, okay. Okay. I probably spelled get item wrong, right? So should implement get item. Right. Because I capitalized that. Does that work? Float D type? Okay, so I can't use D type? Is that what it is? Because I had to do it on this setup. I had PyTorch GPU. I don't know. That's annoying. Shit. Hold on. I can find it. D type. I typed it somewhere. I remember. Okay, there it is. So I just have to write D type. I can't do that. I know I did it in an earlier stream, but that's whatever. Who cares? D type. Nice. And then come on, give me more errors, please. Item. Lengths. Okay, so there's no such thing as item. It's the length property. Hold on, my mom's calling me. I'll be back. Yeah. Okay. I hate this water bottle, bro. Okay. Nice. Okay. Hmm. You have to do a non-check, right? Okay. Pad sequence. Did I not import it? Oh, I didn't import it. Okay. That makes sense. That's so dumb. From torch dot. Oh my god. Yeah. Okay. Torch dot and then where's it? Hold on. What was it? Dot details. Dot and then multi-cell. Where is it? Transcript ID. Come on. So annoying. It's transcripts IDs. Transcript. Line 143. Okay. Is there a way I can show line numbers in Vim? Type. Okay. Oh, okay. So to get to a specific line number, I can just do. Let me try to test that out. So set, and then was it 149, right? Yeah. So no, line 143, and then do I click enter? No. Hold on. Set. Oh, is it? Ah, that's so dumb. Okay. Nice. Okay, so cool. I have line numbers now. Transcripts IDs. So transcripts. Yeah, I pluralized that. Nice. Let's go. Okay. That's it. That's it. We have the transcript IDs. And then okay. Nice. And so what's the next step? Wait, that's so cool. Okay. Does this make no, it doesn't. Fuck. Hold on. So yeah, I have two output channels. Y true. Oh, because Y true is my batch size. Yeah, okay, okay. No. This is good. This is good. This is good. And then my max length is that. Yep. That makes sense. Yeah. Okay. Okay. Let me see. I'm getting kind of tired, but that's good. I'm happy. This is looking great. So now I have my own custom data loader and data set. It's only for this specific problem. Okay. Take a break. Okay. So I need to do that. I need to figure out the reference though. Ribo equals ribo data A2780.ribo. Print ribo dot. Let me look at the repository. It was called ribo get. It's get something. It's get reference. Where is it? Reference name. Print dot reference name. How did I call it? Oh, it's... Wait, what? Oh, wait, no, it doesn't return a string, right? Wait. Return self dot info metadata. Name of the reference, transcript assembly and annotation. Okay. So, what's the error exactly? I mean, is it not so annoying? Oh, okay. Okay, it's Apris V1. So now, okay, so now I know the reference name is Apris V1. Let me write that down. So, shoot, I lost it, right? All right, let me reconnect. That's okay. Okay. Let me put it up. Oh yeah, hold on. I need SSH first. Done. Nice. Okay. What do I need to do? So, reference name for my lab's current ribo files. And it's called Apris V1. And I'm assuming it's going to be human Apris V1, but let me double check. So I'm going to save this, and then let me put up where I'm currently at. You see this? You guys see this? Okay, cool. Let me just exit some of this. Oh, okay. Genome kit. Okay. So this is the documentation for Genome Kit. I already explained it earlier in the stream. For annotations. Okay, so the ribo, if you guys see it, so right here, so if you see on the right side, this reference name, if you look at it, so it's the name, so it's a string. It returns a string, and that string contains the transcript, assembly, and annotation. The output of that, which I had up earlier, was Apris V1. So I'm assuming in this context, the assembly is called Apris, and then the specific version of it is V1. Yeah, and so that's good to know, because in the last meeting, my advisor said it was V2, but he said he wasn't sure, so I'm glad I could check that. Okay. Now, if I look at the genome kit, let me see if... Do they have anything on Apris? Reference genomes. They have V41. Let me see. Okay, maybe Apris is associated with some of these references. Because Apris, reference genomics. It was developed in the GenCode. Okay. Do I know which GenCode version it is? 50. So this is the most recent one, but that's fine. I don't... Okay. M39. So yeah, this was for mice. But it's for 41. Okay. So, what's the next step? It follows GenCode. I know that. So, GenCode will... There's specific IDs that I can currently get from RiboPi, or that I am getting from RiboPi. So I guess the next plan, I'm not gonna do this today. I know that for a fact. But I think the next step is to go back to my embedding script, and then I need to I'm gonna use V41 since it's the most recent, and I know for a fact I'm using GenCode. So I'll use GenCode V41, which is fine because I can just type that into I already have some code that uses genome kit and that. And so, okay. Here, I'll show you guys. So, I know what to do now. This is good. Well, I do need to connect this too. But that's a story for another time. Or a task for tomorrow. Okay. So, let me see. Let me go to stream. Alright. Okay. Okay, so yeah. So V41, let me show you guys the code. I'm gonna have to change this. I need to remove all of this, but I'll just keep it for now. I'm just glad that I have something working. And this dataset looks like it's clean. Well, I have clean data, so I have that benefit. I kind of have the privilege of not running into those errors, but let me... Do I save this? Yeah, I'll save this. Wait, okay. Let me go into the embeddings. So here, at the beginning of this, okay, so right now I'm using V29. I know I should use V41, because that's the most recent version. And then right now, let's see. If I were to, okay, yeah, so this line right here is a transcript, so finding it by the name, that's what I need to change. So I might have to write a for loop, so I'll need to import my script to create the dataset, and then once I make a dataset, I can iterate through that. And instead of doing this sample transcript name, I'll just grab the name for each item, and then I can actually just get the transcript for it. And then I can have a list of multiple transcripts that should be unique, I think. And then maybe, yeah, and then I should be good. And then I can produce, and I have Y true. And now I also have the true label, which I can feed to the loss. And I should be good. I should be good to go. Hold on. Okay. Yeah, so what was I saying? Yeah. So if I type, let me update my goals. So from the ribo files, it's appers v1, and so that means I use genome kits gen code v41, which is the most recently supported version. So let me make a detailed plan to connect data processing and embedding generation scripts. So first thing I need to do well, I could obviously start with importing it, and then let's see. I could import it, and then so first I need to change the gen code version being used to initialize my genome object, and then I have to specify the interval. So I'm feeding the entire reference transcript actually. And I don't know what the length is, but it's pretty big. It's like, yeah, so it's around 117 million. So I have that. Cool. Create dataset using data processing script. Iterate through dataset and grab intervals by transcript name by our data's transcript name. So then okay, not sure. So then when I do that, I wonder if I might have to store the embeddings. Okay, so maybe, and this, I think my advisor talked about this before, like a long time ago, but maybe I have to create my own embedding directory, and then find a way to store. I don't know if I can use Pickle for that, but maybe I could. It might be in my best interest to store those embeddings, because the transcript is very long, and I wouldn't want to, because I know I'm going to be running multiple tests when I actually create the predictive model, or like actually architect it, but okay, maybe create my own and store generated embeddings. So I might have to limit, it may lead to me having to limit generate embeddings .py to just only code that generates the embeddings, to just generation code. And then yeah. And I might have to create, and then eventually even then that might have to lead me to creating own model.py, which then leads me to creating my train.py file. And I know what to do for that. So okay, I might have to break this project up. But for the most part, like, this stuff is there. I have a better idea. 5, I do need to think about more stuff though. I know this isn't it. Work in progress, might need to think of more stuff. Of more steps. That's it. Okay. But yeah, I know for a fact B41. I can probably just change it. No, I'll keep it. I'll just keep that for tomorrow. I might have to remove this. But yeah, this is the big thing right here. That shouldn't be too bad. I think it'll be easier, but we'll see. Okay. Yeah. Let's see. I think I finished what I need to do though. Like, that's, yeah. I finished all the goals I wanted. And I don't know. Okay, then that will wrap it up. I'm gonna end stream and I'm gonna hang out with some friends, probably. I don't know. We'll see. So tomorrow I'm gonna try and make my own data set. Well, oh wait, yeah, I'll add it to the goals, but I need to finish symlinking the rest of the lab data to my own data directory. But that should take like 10 minutes. It's just gonna be very tedious and repetitive. But it's fine. And then from there, I'll have to edit the embedding stuff. But it should be good. It's coming together, and yeah. I don't know when I stream specifically. I say this every time, but I might have to stream earlier. But if I do, then I will see you guys tomorrow. And yeah. Alright. Bye.